Hello everyone, very good evening one and all. Welcome to 𝐂𝐤𝐻 and welcome to the session. We are in lecture number 3 of data structure subject. We have discussed couple of concepts with regard to array data structure in the last 2 classes, and today we will be discussing one more interesting concept, that is three-dimensional arrays. Three-dimensional arrays. So guys, everyone join the session quickly and mark your presence. Hi Haruki. Very good evening one and all once again. Let me know your presence, whoever are watching this live. Please mark your presence in the chat box. How are you all doing, dear friends? All right. In the last class, we have discussed Ashwini Kumar. Yeah, definitely it would be useful even for DA aspirants also. However, I might be giving code in C language, but the logic remains the same, right? In DA you may be required to develop in Python, but the logic remains the same. So the concept will be useful for you undoubtedly, even if you are a DA aspirant. Okay, right. So guys, in the last class we have discussed about two-dimensional arrays, which are array of 1D arrays. We can say these can be stored in the memory in two forms. One, row major order, other column major order. So either in row major order or in column major order, 2D arrays can be stored. And how we calculate the address of 2D array element, in both row major order and column major order, starting from random index, we have discussed, and then we have discussed lower triangular matrix, LTM, and upper triangular matrix, UTM. Lower triangular matrix and upper triangular matrix. So which is lower triangular matrix? If the elements in 2D array below the principal diagonal, including diagonal, are non-zero, above principal diagonal are 0, then you call it as lower triangular matrix. And the opposite, above the principal diagonal including diagonal elements, if they are non-zero, then we call it as upper triangular matrix. And how we will represent this LTM and UTM, and how we print LTM elements and UTM elements, we have discussed, right? So this is what the quick recall of last class. If anybody by chance you missed the last class, it is available in the playlist. You can definitely check whenever you are free. Hi Meenakshi, hello Sudeep. So everyone kindly confirm, am I visible and audible for everybody? Am I clearly visible and audible? Kindly confirm. Yes, Great, that's great. Chalo. So today we will be discussing about this three-dimensional array. 3D array means what we will discuss? How you declare this 2D array, how we initialize this 2D array, and how we access elements of 2D array, 3D array. Along with this, we will also discuss how we find address of 3D array element. Address of 3D array element. Okay? So, without any delay guys, let us start the session. First of all, we know that arrays are basically classified into two types, which are one-dimensional array and multi-dimensional array. Under multi-dimensional array, we get all these 2D array, 3D array, 4D array and so on. Right? So how we actually declare n-dimensional array. It may be, the n value may be anything. So how we declare multi-dimensional array? So first let us see the generic format, means the syntax, the general syntax. Definitely we will be writing the data type of that array, followed by array name, followed by the number of subscripts. The number of subscripts indicates the dimension. What these are? These are what we call as subscripts. So the number of subscripts is equal to dimension of an array. That means if it is a 1D array, we will be writing just one subscript like int x of 5. If it is a 2D array, we will be writing two subscripts like int x of 3 by 4. If it is a 3D array, how many subscripts we write? 3 subscripts. 4D array, 4 subscripts. 5D array, 5 subscripts and so on. N-D array, n subscripts we write, and in every subscript we will mention the size. In how many subscripts we have to mention the size means at least n minus 1 subscripts should be filled with size. N minus 1 subscripts. One subscript you may leave, because based on the number of values that you assign, the remaining size, the remaining dimension value can be calculated by the compiler. That too, when you assign the values at the time of declaration. When values assigned, when values assigned while declaration, then n minus 1 subscripts you have to mention minimum. If you are not assigning any value, you are simply creating an array, no value you are giving, then all n subscripts you are supposed to give. All n subscripts you are supposed to give. Because arrays will take what? Compile time memory. So at the time of compilation, if you do not mention the size in every dimension, array will be having a question mark. How much memory I should allocate for this group? If you give properly all the dimensions size, then compiler will be knowing how many elements are there. Accordingly, the memory will be allocated. If you skip any one or multiple, then the compiler will be having this question mark. Array, how many elements are there in the group? I am not getting proper idea. So how much memory I should allocate? Because arrays will take memory at the compile time. That's why. That is the reason why you are supposed to mention the size when you are not giving the values. Okay. So this is how you declare any multi-dimensional array. So if we talk about just 3D arrays now, 3-dimensional arrays, obviously how you declare it? Data type, array name, followed by how many subscripts? 3 subscripts with size. Every subscript size you will be mentioning. And this size must be integer. This size must be integer. That too, what integer? Unsigned integer. That means it should be positive number and it must be whole number. No fractional value you can give like 3.2, 4.6, 5.9. No. And you cannot give negative values also in the size. So the size data type is what? Unsigned integer by default. So if I am taking the 3-dimensional array, actually what it is indicating? Can I say, dear friends, 3-dimensional array as what? See, it is actually very clear. If I write 1-dimensional array, what it is? Group of elements, of course similar elements. If I say 2-dimensional array, what it is? Group of 1D arrays. That means array of 1D arrays. Right? We can say 2D array as array of 1D arrays. Similarly, when I say 3D array, now you tell me what it would be. Hello, everybody. What it would be? Group of 2-dimensional arrays, isn't it? That means array of 2-dimensional arrays. Isn't it? So whenever you write 3 dimensions in 3D array, the first dimension is telling number of, number means here you should understand total 2D arrays. And the second dimension is telling total 1D arrays in each 2D array. In each 2D array, how many 1D arrays are there? That is what the second number is indicating. And what the third number indicates? Total elements in each one-dimensional array. In each one-dimensional array. For example, see, let us have an example here. Suppose if I write int x of 3, 4, 5. Okay? And from this, what we can understand? One thing we can understand is total elements in the array. Total elements in X is multiplication of all the dimensions, that is 3 into 4 into 5, 60 elements are there. Total how many elements means what we can say? It is the product of all the dimensions, that is 3 into 4 into 5, 60 elements. Okay. And how those 60 elements are organized? They are organized in such a way that there are 3 2D arrays. In each 2D array, in each such 2D array, 4 1D arrays are there. In each such 1D array, in each 1D array, how many elements are there? 5 elements are there. 5 elements are there. So, if I am taking this int x of 3 by 4 by 5, what it is indicating for us? What it is indicating for us? There are 3 2D arrays. Okay. There are 3 2D arrays, and in each 2D array, how many rows are there? How many 1D arrays are there? 4 1D arrays. 1, 2, 3. Okay. 1, 2 array. First row, second row, third row and fourth row. Similarly, in each 2D array, it is not just one. In every 2D array, there are 4 rows, 4 1D arrays. Okay. And in every 1D array, how many elements are there? 5 elements are there. 2, 3, 4 and 5. Similarly, here also 1, 2, 3, 4 and 5. In every 1D array, 5 elements are there. Now, this is the first dimension. The first dimension is giving you the number 2D array number. So it is 0th 2D array. It is first 2D array. It is second 2D array. That means total 3 2D arrays we have. Numbering started from 0. So it is 2D array 0, 2D array 1, 2D array 2. Now in every 2D array, row numbering starts with 0. In every 2D array, row numbering starts with 0. So I am taking that index as j. And in every such 1D array, column numbering also starts with 0. Now it is very simple. Now any element index means you can easily get. So suppose I am looking for index of this particular element. This particular element index I want. So how I write? It is x of, what is the first index? 1. Second index 2. Third index 1. No, we have to write third dimension also, no Sudeep. I means it is in 2D array number 1. In that 2D array, 1D array number 2. In that 1D array, element at index 1. Right? Similarly, if I am looking for this particular value, this particular element index, how we write? X of which 2D array it is? 2D array number 2. In that 2D array, which 1D array? Number 2. In that 1D array, which element? Element index 3. Element index 3. Right? So what would be this index? Everybody tell me what would be this particular element index? Quick. Sudeep, Meenakshi, everyone. It would be what? X of whichth 2D array? 0th 2D array. In that 2D array, whichth 1D array? 1D array number 3. In that 1D array, which element? Element at index 4. 0, 3, 4. Perfect, perfect. Now, finally, you tell me, what would be this particular index? Finally, you tell me, what would be this element index? Two, 0, 2. The 2D array number 2, in that 2D array, 1D array number 0, in that 1D array, element index is 2. Very good. Hope now identifying the indices is clear, everybody? Identifying the indices is clear or not? Clear. Very good. Very good, Meenakshi. Come on guys, everybody please Try to interact, try to be active. Could everybody please respond? Whoever are watching it, kindly take some time and respond please. Hi Nishu, after long time Nishu, how are you? Nishu Kumar. Yeah, chal. Now, how we declare part is done. Now we understood what is a 3D array and how we actually interpret it or represent it. I think it is clear now for everybody. Now, let us move on to initialization. Let us move on to initialization. Yeah, we know how do we initialize any array. We may initialize at the time of declaration, means while creating an array, at that time only we may assign the values. Is it mandatory to assign all the values? No. You may assign one value or two or few or all. It is up to us. It is up to us. So, if I suppose say int x of 3, 4, 5 and if I suppose write print some value x of 2, 1, 4, what would be the value guys I will be getting? What value I get? What value I get? I have not given any value, right? So, what value I get? Sudeep says garbage value, Nishu says garbage value, okay. Meenakshi, Ashwini, Ishika, everybody. So, all are with the garbage value? Correct. Definitely this value will be some random unpredicted value, some garbage value you will get. Okay, okay, fine. If I write int x of 3, 4, 5 is equal to just like this, just an empty braces, just an empty braces. Now what would be the value I get? I have not given any value even now. So again what will be printed? Again what will be printed? If I am trying to print some value, what would be printed? X of 2 by 1 by 4. Now again what will be printed? Garbage value will be printed, but no 0 will be printed. If you assign, if you use assignment operator, whether you give the value or not, it doesn't matter. Compiler treat that the array is initialized. So it will take 0 only. Whether you give one value or none, but if you use assignment operator, then array is treated as, considered as assigned with the value or initialized with the value. We used assignment operator, that's it. That's it. Okay, you can check, undoubtedly you can check. Fine. So, if you use assignment operator at the time of declaration, it would be taking zeros as default value. So now you can understand whether I give one value or two value or all the values, the other values would be zeros. Okay, that is okay. Now suppose I would like to assign all the values. Now it will be 60 values. So let me take some small 2D array just for the simplicity. Let's say 2 by 3 by 4. Now also I have to give 24 values. One way to initialize is give all the values separated by comma. Like I say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. I have given all the values. Now comes the question. Sir, how the values are actually assigned? Please understand, values are always assigned dimension wise. In any array, values are always assigned in the dimension order. In the dimension order. What does that mean? Sir, we did not understand dimension order means, sir. Let me tell you. This is one 3D array and this is one 2D array, sorry. That is one 2D array and this is one 2D array. We have two 2D arrays. We have two 2D arrays, right? I have taken two 2D arrays. First dimension, first 2D array dimension would be, index would be 0. Second 2D array index would be 1. Fine. In every 2D array we have 3 rows. So I am taking 3 rows. In every 1D array I have 4 elements. That means I am taking 4 columns. Okay, and this indexing also starts with 0. Column indexing also starts with 0. Okay, what I am telling? What I am telling? Values are always assigned in the dimension order. That means first dimension is what? The third dimension. I mean this I0, I1 Wallah dimension, right? So first I equal to 0 2D array is filled. I is equal to 0 2D array. That means the values are taken in what order? First 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So first I is equal to 0 is filled. Then I is equal to 1. That too again in the recursive manner, again in the second dimension order. That means first row, second row, third row. First row, second row, third row. Again, in the third dimension order, first element, second element, third element, fourth element, like that. So the next values will be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, somewhere I missed, 11, 13, 15, 17, 19, 21, 23. Yes, it would be something like k variable map, but in k variable map we take 0, 0, 0, 1, 1, 1, 1, 0. Nishu, their indexing will be different. It looks like that, but that is different, this is different. Yeah, anyway, do you understand this assignment, guys? Everybody? Do you people understand this assignment? Yes or no? Ashwini Kumar, Meenakshi, Nishu, Sudeep, Shan, everyone? First 2D array, then second 2D array. Okay. Sir, is this the only way? Sir, is this the only way to assign? I mean, initialize? No. We can also assign in this order. Int x of 2, 3, 4. We can also assign in this way. First 2D array values you can actually give in a nested curly brace. First 2D array values. What? I have given what? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then second 2D array values. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. Like this you can give. Or in the 1D array order also you can give. This you are giving in 2D array order, or else you can give in the 1D array order. For each 1D array also you can assign the values. How? First 1D array is 2, 4, 6, 8. Second 1D array is 10, 12, 14, 16. Third 1D array is 18, 20, 22, 24. Total how many 1D arrays we have? 1, 2, 3, 4, 5, 6 1D arrays. So in the 1D array order also you can give. For fourth 1D array, 1, 3, 5, 7. Fifth 1D array, 9, 11, 13, 15. Last 1D array, 17, 19, 21, 23. Like this also you can give. Okay? Suppose, okay, everybody listen carefully, look at the screen carefully, look at the board carefully. Yeah, whenever you are grouping the values, you have to write the curly braces surrounded by the outer curly brace. Because these are like 1, 1 value, if you assume 1, 2, 3, 4, 5, 6 values you are grouping. It is like a group of 6 small groups, no? It is, outer one is also a group. So when you are grouping something, then you are supposed to put it in curly brace. Okay. Now please look at the board, guys. If suppose I write int x of 3 2 3 4 2, and suppose if I am mentioning the values like this, 11, 14, 15, 19, 20, 25, 1, -3, -2, 0, 0, 0, -1, 7, 9, 11, and let's say 17. Okay. Now if I am looking for x of 1, 2, 0, what would be the value? X of 2, 1, 1, what would be the value? X of 0, 3, 0, what would be the value? Yes. Try to assign these values. Try to assign these values, dear friends. Let's see. First, there are three 2D arrays. So I am taking 3 2D arrays. Okay, and then one more. Three 2D arrays I have taken. In every 2D array there are 4 rows. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And in every row there are 2 elements. Now what I said, we can also assign the values in 1D array sequence. So this is what 1D array sequence we have got. So how the values will be assigned? 11, 14, 15, 19, 20, 25, 1 minus 3, minus 2, 0, 0, 0 minus 1, 7, 9, 11, 17. 1D arrays are assigned. We know the remaining will be by default zeros. Now you look at the index. The first index is I, so 0, 1, 2. Second index is J, 0, 1, 2, 3. Third index is K, 0 and 1, we have only 2. Right? Now I am looking for 1, 2, 0. 1 means the first index means 2D array number 1. In that array number 2, index 0. So this would be 1, 2, 0. This is what? 1, 2, 0. Now 2, 1, 1. 2, 1, 1. This is what? 2, 1, 1. Then 0, 3, 0. 0, 3, 0. This is 0, 3, 0. So the values are 0, 0, 20. Hope it is clear for everyone. Hello? Great. That's wonderful, wonderful. So this is how 3D array is assigned with the value, or values are initialized. Now, how we find address of 3D array element? Let's say I am taking a 3D array of 2 by 3 by 4. 2 by 3 by 4. That means I am having two 2D arrays. In each 2D array I have 3 rows. In each row I have 4 columns. Let the base address is equal to, assume, let the base address is equal to some 100, and one element size is, let's say, 4 bytes. Now how the addresses will be, means how these values will be stored in the memory? As I said, dimension order. Of course here row major, column major will come when it comes to this 2D arrays, but as we are C language or CPP, Java, Python follow row major order, I am going with row major only. Okay, by default I am going with row major only. So, what would be the addresses, dear friends? The addresses would be something like this. Oh my God, it is not at all visible. Chalo. 100. Next element will be this 108, 112, 116, 120, 124, 128, 132, so on, 136, 140, 144, go on. So, next, in the next address, next 2D array elements will be starting. So, it would be 148, 152, 156, 160, 64, 68, 72, 76, 80, 84, 88 and 92, right? So, now you want any element address, you can easily get it. So, I am looking for address of x of 0, 2, 3, 144, address of x of 1, 1, 1, 168, address of x of 1, 2, 2, 188, address of x of 1, 0, 0, 148, and somewhere like I want some address, this one, address of x of 0, 1, 2, 124. We can easily say when the dimensions are small like this, we can easily say. That is what, Nishu, I am telling. What if I give int x of 20, 40, 60. Now I want address of x of 15, 32, 48. What? Will it be possible, feasible to draw all 2D arrays like this, all values like this, and then find the address? Is that feasible when the dimensions are big? So, definitely we could have some or the other possibility, some approach, some formula. So, what is that? So, let us end today's session with address of, okay, let me put it. Let x of d1, d2, d3 be a 3-dimensional array. Okay, and let b is equal to base address, and n is size of one element. And let I be first index, j be second index, k be third index. Whose address we wanted to find? Those addresses, those indices. Okay. And we know one thing. In arrays, default indexing starts from 0, but it is not mandatory, or we can also start with some other index. We have that concept also. So let the start index of first is I0. Start index of j is j0. Start index of k is k0. Okay, or else let me take is, js, ks, starting indices. Now, how I find address of x of I, j, k? That is base address plus first index I into second dimension multiplied by third dimension. Okay, here wait a minute. When I say I, it is not again I. I index starts from is. So it should be I minus is multiplied by second dimension d2 multiplied by third dimension d3 plus index j, which starts with js, multiplied by third dimension d3 plus last index k that starts with ks whole multiplied by size of each element n. So if you properly look at the formula for 2D array, for two-dimensional array, I have given the similar one. I am trying to find address of particular element means I am actually doing what? Counting how many elements so far before that particular element, how many elements went on, means how many rows went on, how many columns went on. That actually I am finding. In this I am finding, if I am trying to find the address of this place starting from the base address till here, how much distance, accordingly we are getting it. Okay. Nishu, for column measure, this would be k minus ks into d2, k minus ks into d2 plus j minus js. That would be the difference. If it is a CMO, okay. So this is for row major order only. If at all you are looking for the column major order, base address plus I minus is into d2 into d3. This will not change because column major, row major is for the 2D array. This is what the part of 2D array. So here you will get the change k minus ks multiplied by d2 plus j minus js whole multiplied by n. Okay. So this would be the thing. So using this you can find out the address of any element in the three-dimensional array whose size can be any. Now you can use this formula and find any element address. Clear? So that's all for today, guys. So today key takeaways for you will be, what is a 3D array? It is not just an array with 3 dimensions. As we have discussed, it is array of 2D arrays. And how do you declare it? How do you initialize it? And how do you access each element with the index? And how you print address of, or how you find address of any element in both row major, column major, starting from any random index. Right? Hope whatever we have discussed in today's class are clear for you, and is this clear, guys? Please confirm. And the next topic, tomorrow we will discuss arrays as pointers. Arrays as pointers. When? Tomorrow sharp at 7 p.m. Thank you all for joining the session. Keep attending the sessions regularly so that you will get the confidence. I wish you all a very happy learning, happy coding. See you tomorrow sharp at 7 p.m. on our Wallah English channel. Till then, have a great time. Take care. Good night, everybody. Jai Hind.